Welcome back to Science to Sleep By. Tonight, we drift through the silent corridors of the cosmos where something strange has happened. NASA's Deep Space Observatories captured images of an object so peculiar, it defied immediate explanation. They called it 3I Atlas, the third known interstellar visitor to ever enter our solar system. But when new images arrived high resolution, impossible patterns began to appear, and for a brief moment, NASA's quiet control rooms filled with a wave of unease. What was this thing really? A comet? A fragment of alien technology? Or something far older and far stranger than anyone expected? Tonight, we'll travel through those mysterious images, the scientific debates, and the eerie calm that followed NASA's panic.so lie back, take a deep breath, and let your mind float among the stars. There are moments in astronomy when silence carries more meaning than words, when the hum of the universe seems to shift, and an unexpected blip of data transforms everything we think we know about our cosmic neighborhood. The arrival of 3I Atlas was one such moment. It began quietly, as many extraordinary discoveries do, buried within streams of ordinary observational data. In early 2024, a team operating the Atlas survey system in Hawaii noticed something unusual: a faint, fast-moving object streaking across their nightly data. At first glance, it seemed like any other near-Earth comet, but as astronomers began to calculate its trajectory, a realization dawned. This object was not bound to the sun, its orbit was hyperbolic, meaning it had come from outside the solar system. The third interstellar object ever detected by humanity had arrived, and NASA immediately took notice. The designation 3I marked its place in a short but revolutionary lineage. Before it, there was 1I Oumuamua, the cigar-shaped mystery from 2017, and 2I Borisov, a more comet-like traveler discovered in 2019. Each one had shattered old assumptions about our cosmic isolation. And now, here was a third, a faint speck in the data, whispering across the void, its origins unknown. NASA's early analysis revealed an approach vector that didn't match any known stellar path. It wasn't coming from a familiar star system, nor was it easily traceable to a nearby cluster. It was, quite literally, from nowhere. The object's motion suggested it had wandered interstellar space for, perhaps millions of years before crossing our solar boundary. NASA's Planetary Defense Coordination Office flagged the object for immediate study. Observatories from Chile to Arizona turned their instruments toward the patch of sky where Atlas had first seen the faint intruder. As the data came in, scientists began to feel that familiar rush of discovery tempered by unease. This wasn't just a new rock. Its speed was extraordinary, faster than almost any natural object observed so close to Earth's orbit. Its trajectory indicated it would pass relatively near the sun, but at a distance that would prevent disintegration, allowing scientists an extended window to study it. Within days, 3I Atlas became a name whispered in every NASA communication thread related to near-Earth objects. Researchers who had worked on Oumuamua were brought back for consultation. The comparison was inevitable. Yet, there was something fundamentally different about this one. Where Oumuamua had reflected sunlight erratically and accelerated without a clear cause, 3I Atlas seemed to move with strange precision. Its light curve fluctuated in a rhythm too consistent, too structured, as if it were tumbling in a deliberate way. This immediately raised questions among NASA scientists. Could this object be a fragment of something artificial? But NASA is not an agency prone to superstition. Every anomaly has to pass through layers of verification, mathematical modeling, and peer review. The panic, if we can call it that, was not public. It unfolded quietly, in labs and digital conference rooms. The images and light curves that came in didn't make sense at first. Its brightness shifted in a repeating pattern, suggesting a shape that was neither spherical nor jagged, like a comet nucleus. Instead, it behaved like something flat, possibly disc-shaped or elongated, rotating on an odd axis. These were only early inferences, but they echoed the uncertainties of 1I Oumuamua, reigniting speculation that the object might be an engineered relic, a probe, perhaps, or a fragment of an ancient interstellar construct. As the object drew closer to the sun, the reality of what NASA was witnessing became harder to ignore. Spectral data from infrared telescopes began showing reflective qualities inconsistent with rock or ice alone. This wasn't the typical chemical fingerprint of a cometary body. It lacked the strong signatures of volatile compounds, water, methane, carbon dioxide, that normally dominate such readings. Instead, there was a flat spectrum, smooth and unyielding, reflecting light in a manner that suggested a hardened, possibly metallic surface. NASA's Astrophysics Division called for cross-verification with European and Japanese observatories. If this was an error, they wanted to find it fast. The most striking moment came when the Hubble Space Telescope captured its first images. Even though 3I Atlas was still faint and distant, its outline against the starfield appeared unnatural. There was no visible tail, no cloud of vapor or dust, as one would expect from a comet nearing solar warmth. It moved cleanly, almost surgically, through the light of the stars behind it. Observers at NASA's Goddard Space Flight Center described the images as uncomfortably sharp, with crisp reflection patterns that shifted slightly between exposures. In a matter of days, the data began circulating among higher-level committees, and quietly NASA increased observation time from other instruments, diverting telescope schedules that had been booked months in advance. Publicly, NASA remained calm. Their press statements were cautious, referring to 3I Atlas as a newly detected interstellar comet of unusual reflectivity. But internally, the tone was very different. There was confusion. Too many unexplained parameters in its trajectory, rotation, and spectral composition. Some researchers suggested the object might be wrapped in a non-volatile shell of carbon compounds, protecting its interior from erosion. Others speculated it could be a fragment of a much larger interstellar body, shattered long ago and sent drifting into space. Yet, a smaller group quietly entertained a different hypothesis. What if this was a probe? Not functioning necessarily, but ancient. A drifting, silent machine that had outlived its purpose, now caught by chance in our gravity's pull. Astronomers across the world began racing to collect as much data as possible before it left. Unlike 2I Borisov, which displayed classic cometary features, 3I Atlas behaved more like something under subtle control. Its trajectory adjusted slightly after solar perihelion, defying the predictive models that had been built from weeks of observation. The adjustment wasn't dramatic, but it was deliberate enough to trigger what NASA insiders later described as full analytical priority mode. Every available telescope was tasked to track it, every sensor recalibrated to maximum sensitivity. NASA's Jet Propulsion Laboratory ran simulations of possible explanations. Outgassing could cause such motion, they said, if the surface had localized jets of gas that pushed it slightly off course. But when no signs of gas were detected, even that explanation faltered. In scientific discussions, this kind of uncertainty is fuel for curiosity. But within NASA's control centers, uncertainty about something that behaved like a spacecraft was enough to send quiet waves of panic. No one wanted to say it out loud, but the question lingered. What if 3I Atlas wasn't just a rock? And so, as it passed through the outer reaches of the solar system, NASA tracked every flicker, every spectral variation, every improbable pattern that appeared in its faint light. The object had come uninvited, traveling for perhaps eons through the deep, dark, only to be seen by human eyes for a brief moment in time. And as it continued its silent journey toward the stars beyond, the scientists who had first glimpsed it could not shake the feeling that something about it was watching. Back when NASA's first images of 3I Atlas began to arrive, the control rooms at the Jet Propulsion Laboratory and the Goddard Space Flight Center were filled with an atmosphere of restrained awe. There is something sacred about the first time light from an unknown world or object strikes a human-made sensor. It's the moment when numbers turn into images, when data becomes something that can be seen, touched by human curiosity. The raw frames came in slowly long exposure captures from the Pan-STARRS telescope, supplemented by observations from the Hubble Space Telescope and NASA's NEOWISE infrared platform. The expectation was that these images would show a faint, blurry smudge, like every other interstellar object ever captured from afar. But instead, the data revealed something patterned. At first, the team thought the pattern was a data artifact, a digital glitch from pixel noise or image stacking. Yet, after multiple corrections, calibrations, and cross-checks, the same geometry persisted. 3i Atlas didn't appear as a diffuse, randomly shaped object. It showed consistent angles, linear reflections, like facets of a surface. Not jagged, not smooth, but strangely ordered, as though the sunlight glancing off it was bouncing from panels, not natural surfaces. The light intensity fluctuated at regular intervals, repeating with such precision that it drew immediate comparisons to mechanical rotation. For a moment, the analysis software suggested a repeating brightness signature every 5.3 hours, as if the object rotated with clockwork rhythm. This was not typical behavior for an interstellar comet or asteroid. Natural bodies spin irregularly due to uneven mass distribution and collisions, their brightness fluctuating in chaotic, non-repeating ways. But 3i Atlas's signal was eerily consistent. In early internal reports, one NASA astrophysicist described it as too perfect to be random, when other observatories in Chile and Spain confirmed the same periodic light variations. Curiosity turned into unease. If this were an ordinary rock, its reflectivity shouldn't obey such patterns. It was as if it were broadcasting through sunlight, flickering in precise intervals, a cosmic Morse code written in glimmers. NASA teams immediately began layering the images, aligning them against known reference stars to rule out distortion. The object remained consistent, its shape, retaining what appeared to be a geometric structure, even across multiple exposures taken hours apart. Some frames showed bright edges that aligned in a near-symmetrical formation, lines forming across the object's reflected silhouette. To the naked eye, it resembled the flattened glint of a metallic shard turning in darkness. To scientists, it was a nightmare of contradictions. The higher resolution imagery from Hubble only deepened the mystery. When its powerful optics finally resolved 3i Atlas more clearly, analysts noticed faint, rectangular shadowing along one side, features that couldn't be explained by natural topography. It was as if parts of the object were smoother and more reflective than others, forming an alternating sequence of dark and bright regions. The ratio of these patterns stayed remarkably stable over time. For an object supposedly made of ice and dust, tumbling unpredictably through solar radiation, this level of uniformity was beyond strange. Some of the data analysts even proposed it might not be a single solid object at all, but several joined fragments, perhaps thin structures bound together, rotating as one. NASA's Visual Analysis Division brought in photometric experts to decode what the brightness signatures might mean. The working theory at the time was that 3i Atlas possessed a highly reflective material, possibly a crystalline or glassy surface, unlike anything previously observed. It might have formed deep within another solar system under conditions of pressure and radiation that sculpted unique minerals. But others weren't convinced. The pattern, they said, was deliberate in its uniformity, and its spectral reflection did not match any natural silicate or metal oxide compound cataloged in NASA's databases. The reflectivity curve was smooth and constant to constant, suggesting something artificial or engineered. Inside NASA's Astrophysics Science Division, conversations became unusually tense. Scientists are trained to dismiss sensational interpretations, but this object was resisting classification. Each attempt to simulate its reflective behavior in computer models failed to reproduce the observed data. The geometry of the reflections implied a flat or layered structure rotating precisely, as though stabilized by design. Some analysts half-jokingly called it the solar panel comet. Others began comparing it to theoretical light sails, large, thin constructs proposed for interstellar travel by using radiation pressure as propulsion. It was absurd to imagine such technology drifting into our solar system, and yet, the images seemed to whisper that very possibility. The first infrared composites from NEOWISE added another layer of confusion. The object emitted almost no detectable heat. It absorbed sunlight, but reflected it with extraordinary efficiency. Comets and asteroids always warm slightly as they near the sun, releasing faint plumes of vapor detectable in the infrared spectrum. But 3I Atlas remained cold, almost inert. The absence of a heat signature was the loudest silence of all. It suggested a material designed to withstand solar radiation without reacting, without shedding gases or losing mass. This characteristic alone made NASA's Planetary Science Division issue a quiet internal alert, requesting immediate follow-up observations. When the combined data from different telescopes were processed into a composite visualization, the image stunned the team. The object appeared as an elongated, rotating form, its dimensions difficult to estimate, but its structure disturbingly organized. Faint diffraction lines around it created interference patterns rarely seen in natural imaging. These interference patterns hinted that the object's surface might be partially smooth and partially angular, like a folded sheet of something rigid. The light reflected not diffusely, but sharply, as if off manufactured material. It wasn't evidence in the strict sense, but it was enough to push NASA into a full data reevaluation mode. To verify what they were seeing, NASA reached out to the European Space Agency for independent observation through the Very Large Telescope in Chile. The European team confirmed similar readings, consistent reflectivity, absence of thermal emissions, and rotational regularity. They even reported a faint secondary reflection, a smaller glimmer appearing near the main object, possibly a detached fragment or an accompanying body. It was fleeting, visible for only a few frames, but enough to deepen the intrigue. What kind of object moves through space with companion fragments rotating in sync? The images, now cleaned and enhanced, began circulating among senior researchers, astrophysicists, and orbital analysts. No one could quite define what they were looking at. To the untrained eye, it might have resembled an oddly shaped comet core. To those who understood the mathematics of light and shadow, it was something else, something structured. Patterns that shouldn't exist in the natural randomness of cosmic debris. Across NASA's internal channels, hushed discussions broke out. Could it be a chunk of a shattered exoplanet's crust? Could it be an interstellar relic, some kind of natural crystal formation sculpted by the vacuum over eons? Or was it, impossibly, a fragment of alien design, a derelict left adrift between stars? Officially, the agency's position remained cautious, anomalous, but explainable. Yet within those quiet moments, as scientists compared the latest imaging data under the sterile glow of laboratory monitors, a rare feeling rippled through them, something between fear and wonder. Because what they were seeing didn't just challenge physics. It whispered of intention, of design, of something waiting to be understood from the very beginning. 3I Atlas defied every model that NASA used to classify interstellar visitors. When its trajectory and brightness patterns were first analyzed, researchers expected the object to resemble something familiar or rough. A regular body, shaped by cosmic collisions and erosion over billions of years. But as high-resolution data poured in from observatories across the globe, it became clear that 3I Atlas was not an ordinary comet or asteroid. Its geometry broke the rules. The way it reflected sunlight didn't align with the physics of natural bodies. The angles of reflection, the consistency of its light curve, the precise way it seemed to shimmer and fade as it rotated, all of it pointed to something symmetrical, something structured. The more NASA tried to fit it into known categories, the more it slipped away from explanation. In the early days of observation, NASA's photometric analysts noticed that 3I Atlas's brightness curve didn't just fluctuate, it pulsed. Unlike tumbling asteroids that scatter light unpredictably, this object showed a repeating rhythm of reflection, almost as if it were rotating on a stable axis. Its brightness increased and decreased at perfect intervals, indicating a rotation so balanced it could only occur if the object's mass distribution were even, something almost never seen in natural cosmic debris. When the modeling team plotted the light variation against its orbital motion, they found that the reflection angles suggested flat planes or smooth surfaces, possibly arranged at geometric orientations relative to one another. Some described it as too engineered to be random. As the object approached its closest point to the Sun, or perihelion, telescopic images became clearer. Observers at NASA's Goddard Space Flight Center noted something extraordinary: the way sunlight reflected from its surface changed depending on its orientation, as though it had edges. When scientists reconstructed a three-dimensional model using reflectivity data, the result resembled a flattened, elongated object, much like a slab or a blade tumbling gracefully through the dark. The best estimate placed its length somewhere between 300 and 400 meters, with a thickness less than 1/10 of that size. This made it thinner and more elongated than any known comet nucleus. It wasn't cigar-shaped like Oumuamua, nor rounded like Borisov. It was something in between angular, flat, and eerily symmetrical. The next breakthrough came from polarization analysis. When light reflects off a surface, its waves align in specific patterns, revealing clues about the texture and material composition of that surface. The polarization signature from 3I Atlas shocked researchers. It was remarkably uniform, almost mirror-like. Natural rock or ice tends to scatter light in chaotic ways, but this object reflected light in consistent directions, suggesting that its surface might be smooth, possibly metallic, or coated with a glass-like sheen. Some even speculated that it could be composed of an unknown alloy or interstellar mineral that forms under extreme pressure in ancient stellar environments. Yet, the consistent polarization pattern suggested more than mere material. It suggested geometry, the kind of structure shaped by intent, not by chance. When the James Webb Space Telescope turned its gaze toward 3I Atlas, it captured mid-infrared data that deepened the mystery. Instead of the expected thermal glow, Webb detected cold, hard reflections. The object barely absorbed any heat, implying that it was made of a highly reflective material that minimized energy retention. Such efficiency is rare in nature, but ideal for artificial construction materials that reflect most radiation instead of absorbing it, preserving structural integrity over long journeys through interstellar space. The Webb team also noted faint variations along its edges, like panels reflecting at slightly different angles, producing subtle fluctuations in infrared brightness. To some within NASA, this pattern resembled a form of segmentation sections of a larger surface, perhaps broken or folded. As the shape models improved, a startling idea began to emerge among the researchers. What if 3I Atlas was not a single monolithic body at all, but rather a fragmented or modular object, pieces of something larger that had drifted together or once belonged to a greater whole? Its rotation appeared oddly controlled. Even as it spun, its orientation relative to the Sun maintained a subtle alignment, suggesting either a stabilizing internal structure or an incredibly balanced mass. Theories began to pour in. Some argued that it might be a natural crystal-like formation born in the turbulent heart of another star system, sculpted by radiation pressure and ancient collisions. Others proposed that it could be a relic of broken sail, a fragment of interstellar debris from a civilization long extinct. The more NASA studied its shape, the less it resembled any known class of celestial body. Its surface brightness ratio indicated a high albedo, far greater than expected for a comet or asteroid. Most comets have dark, carbon-rich crusts that absorb light, but 3I Atlas reflected up to 80% of the sunlight it received. This was unheard of in known interstellar materials. The hypothesis that it might contain a frozen shell of hydrogen or nitrogen was briefly considered, but quickly dismissed. Such ices would sublimate rapidly when nearing the Sun, producing visible jets or tails. Yet, 3I Atlas remained silent, and still no tail, no vapor, no outgassing. It simply glided, smooth and steady, through the solar glare, its geometry unyielding. In the image stacks captured during its closest solar pass, NASA scientists noticed an even more peculiar phenomenon. As the object rotated, its reflected light briefly intensified at the same angle every cycle, creating a sharp spike of brightness. This phenomenon, known as a specular reflection, occurs when light bounces off a flat, mirror-like surface directly toward the observer. The precision of this reflection left scientists speechless. For such reflections to occur consistently, the surface would have to be nearly perfect in alignment, maintaining its geometry across countless rotations. Nature rarely creates surfaces with that level of precision. In engineering, however, such symmetry is commonplace. NASA's data analysts began running simulations to explain the reflections. Could it be a naturally occurring monolith, carved by billions of years of collisions and erosion? Could random chance create something that mirrored the appearance of design? Most models failed to reproduce the exact patterns observed. Even in the most extreme conditions, metallic asteroids, compacted silicate structures, or cryogenic ice slabs, the predicted light behavior did not match. The only models that fit closely were those representing thin, flat objects, shapes resembling panels or sails. As the object continued its path out of the inner solar system, the geometry remained stable. There was no tumbling decay, no sign of structural collapse or fragmentation under solar stress. Its rotation remained rhythmically steady, almost serene. To NASA's engineers, it was as if the object had some form of passive stabilization, a distribution of mass or internal structure that counteracted wobble. Such equilibrium is almost impossible for irregular natural objects, but routine for artificial constructs. The strange geometry of 3I Atlas became one of the most debated topics within NASA and beyond. Every image, every frame, seemed to mock the simplicity of human explanation. The reflections danced across its surface like signals written in light, hinting at the possibility of a design we could not yet decipher. Some scientists privately speculated that it could be an artifact of immense age, a remnant from a time before our sun was even born, drifting between the stars as a relic of cosmic civilization. Others insisted that extraordinary claims required extraordinary evidence, and that the object's geometry, however strange, might still be explained through physics not yet fully understood. But one thing was undeniable: 3I Atlas had shown humanity a shape that should not exist, a reflection pattern that seemed deliberate, and a mystery vast enough to unsettle even the most rational minds in NASA's observatory. The early data from 3I Atlas began to challenge everything the models predicted. NASA's internal communication networks shifted from routine observation mode to a level of urgency rarely seen outside of planetary defense alerts. The discovery had started as a quiet curiosity, another visitor from the interstellar dark. But by the time the first detailed reflection patterns arrived, the tone across NASA's divisions had changed. The phrase, non-standard object behavior, appeared in several internal memos within days. It wasn't panic in the dramatic sense, but it was tension, calculated, disciplined, scientific tension. The kind that happens when something unexplainable emerges, and the world's most advanced minds are forced to confront the possibility that they might not fully understand what they are seeing. The first major alert was issued by the Planetary Defense Coordination Office, the same division responsible for monitoring near-Earth objects. Their task was not simply to guard against asteroid impacts, but to coordinate global observation efforts when anomalies appeared in deep space. Within hours of recognizing that 3I Atlas's motion and reflection patterns didn't match any known cometary or asteroid behavior, NASA triggered a priority tracking request. This type of alert doesn't go public, it moves quietly through encrypted channels, reaching teams in Chile, Hawaii, Spain, and the Canary Islands, as well as space-based observatories like Oumuamua, and eventually the James Webb Space Telescope. The alert was simple but urgent. Object exhibits irregular reflectivity and rotation. Sustained observation required. Cross-spectral verification requested. To the untrained eye, it was bureaucratic language, but to astronomers, it was a signal that something about this interstellar body had gone off script. Every telescope capable of tracking faint moving objects was redirected toward 3I Atlas. Observation windows were reshuffled, schedules canceled, and data pipelines rerouted to NASA's central processing centers. In a matter of hours, the object had gone from an obscure detection to a top priority target across multiple continents. Inside the Jet Propulsion Laboratory in Pasadena, the data team began coordinating a continuous observation stream. They needed to know if the unusual brightness patterns were an illusion, perhaps caused by imaging interference, cosmic rays, or instrument noise. But each new image confirmed the anomaly. The reflection was real, the geometry consistent, and the trajectory unexplainably stable. The speed of the object was measured at over 65 kilometers per second relative to the Sun, faster than any known asteroid or comet could maintain without external force. That alone demanded attention. When NASA's Orbital Mechanics Division ran trajectory simulations, they noticed something even more unusual. 3I Atlas was decelerating slightly as it approached the inner solar system. Not dramatically, not enough to suggest propulsion, but just enough to deviate from standard gravitational expectations. Normally, interstellar visitors accelerate as they fall toward the Sun's gravity, but 3I Atlas seemed to resist, as if something about its orientation or structure was countering that pull. Radiation pressure could explain a small portion of this, especially for light, reflective surfaces, but not at this scale, not with this precision. The models diverged. The equations refused to balance. At NASA's Goddard Space Flight Center, engineers initiated what they called a double-blind verification. Two separate teams were assigned to analyze the same raw data without communication. One would approach it as a natural astrophysical event. The other would evaluate it as a possible artificial construct, purely for the sake of comparison. Both teams returned with results that defied comfort. The natural model could not reproduce the observed motion, and the artificial model required assumptions that seemed impossible: materials beyond known strength limits, energy sources without detectable emissions, and surface properties that behaved like engineered composites. Within 48 hours of the alert, NASA expanded coordination to include the European Space Agency, the Canadian Space Agency, and Japan's JAXA observatories. All were instructed to gather as much data as possible before the object left the inner solar system. Emails circulated through encrypted systems describing 3I Atlas as a non-volatile, high-reflectivity interstellar body of uncertain classification. The language was carefully chosen, technical, measured, yet loaded with quiet apprehension. When NASA uses the phrase uncertain classification, it means something has stepped outside the dictionary of known physics. The internal chatter grew as data continued to arrive. Teams at Caltech, Harvard, and MIT were invited to review portions of the dataset under non-disclosure conditions. This was standard protocol for sensitive or potentially controversial findings. NASA's administrators wanted to avoid speculation, especially the kind that could spill into the media and ignite public confusion. But even as confidentiality was enforced, word began to leak through informal channels. A few astronomers hinted on social media about an interstellar oddity, sparking curiosity among amateur astronomers and science enthusiasts. The speculation escalated, forcing NASA to release a brief public statement downplaying the significance. The agency described 3I Atlas as an interstellar comet with unique observational properties. Behind the scenes, however, no one was convinced. The panic mode, as some insiders later called it, wasn't the chaos of alarm, but the intensity of silence. In NASA's deep space tracking rooms, lights dimmed as analysts stared at streams of shifting numbers. Graphs plotted angles of reflection, heat signatures, rotational vectors. Each confirmed something odd, something that didn't belong. The room carried a strange, heavy quiet, the sound of people realizing they might be glimpsing something unprecedented. At one point, when Hubble transmitted a new image showing sharp-edged shadows across the object's surface, an engineer reportedly whispered, "That's not a rock." It wasn't an official statement, but it was the sentiment few dared to voice aloud. Meanwhile, the communication frequency between NASA's divisions surged. Memos moved at all hours between the Planetary Science Division, the Astrophysics Science Division, and the Office of Public Affairs. Drafts of potential explanations were written, revised, and discarded. Could it be a fragment of an exoplanet's crust? Could radiation pressure alone explain the strange motion? Could its reflective patterns be the result of unknown mineral composition? None of the theories fully matched the evidence. NASA's most experienced scientists, men and women who had studied comets for decades, found themselves without a satisfying answer. As the object continued to move through the solar system, The urgency of observation grew. Every hour mattered. The Deep Space Network, usually reserved for communication with spacecraft, was tasked to assist in high-precision radar measurements. The data that came back was inconclusive. The radar echoes were weaker than expected, as if the surface absorbed or redirected radio waves instead of scattering them. This was another anomaly. Natural objects with rough, rocky surfaces returned strong radar signals. 3I Atlas returned almost nothing. It was as though it was designed to vanish into the background of space. By this point, some within NASA privately discussed contingency protocols. If this object were confirmed to exhibit behavior consistent with artificial construction, something no one was ready to say publicly, what would the response be? There were no established procedures for contact, no protocols for communication with uncrewed, drifting relics of unknown origin. The question was too large, too abstract, and too dangerous for open discussion. Officially, 3I Atlas was still a non-volatile interstellar object, but internally, the mood had changed from scientific curiosity to guarded vigilance. The coordination network now extended beyond NASA. The European Southern Observatory provided additional imaging. While the Canadian CHIME telescope searched for radio emissions, none were found. Even so, NASA kept listening, running background scans through its deep space network, just in case the object emitted faint electromagnetic noise. It didn't. 3I Atlas moved in complete silence. No signals, no pulses, no transmissions, only light, reflecting in strange, rhythmic patterns that repeated every few hours like a clock ticking across the void. The silent, ordered rhythm was what unsettled the scientists most. For all the data they had gathered, for all the resources they had mobilized, they still couldn't explain why it moved the way it did. The alert network stayed active for weeks, long after the object had passed perihelion, tracking its outbound path into the deep cold of interstellar space. And even as the world slept, NASA's observatories remained fixed on that tiny, distant light, chasing the unknown pattern that shimmered across its surface. Unwilling to admit what many quietly feared, that the universe might have just spoken in a language they weren't yet ready to understand. Spectral analysis is one of NASA's most powerful tools, a kind of cosmic fingerprinting that reveals the invisible story of an object through the light it reflects and emits. Every rock, every cloud of gas, every celestial fragment carries a spectral signature that tells scientists what it is made of, how it formed, and even how it behaves in the vacuum of space. When NASA trained its instruments on 3I Atlas, scientists expected to find a familiar pattern, signs of carbon compounds, frozen gases, or silicate minerals that make up the typical bodies wandering through the galaxy. What they found instead was a spectrum that refused to tell the truth. The light coming from 3I Atlas didn't match any known template. It was, in the words of one analyst at the Goddard Space Flight Center, a signature that looked like it was hiding something. The first spectral readings came from ground-based observatories using visible light spectrographs. These instruments split the incoming light into its component wavelengths, creating a pattern of peaks and troughs that correspond to specific elements and molecules. For a normal interstellar comet, scientists would expect to see distinct absorption lines for water, carbon monoxide, methane, or ammonia. But 3I Atlas displayed none of them. Its spectrum was unnaturally smooth, without the dips and valleys that reveal chemical bonds. To the scientists reviewing the data, it was as if the light itself had been stripped of its story, as though something about the object's surface prevented its true composition from being seen. When NASA's infrared instruments joined the study, including NEOWISE and later the James Webb Space Telescope, the anomaly deepened. In the mid-infrared range, natural bodies radiate heat absorbed from sunlight. The amount of heat depends on their albedo, or reflectivity, and their composition. But 3I Atlas emitted almost no detectable infrared radiation. It was cold, far colder than it should have been for an object exposed to sunlight at its distance. It reflected light efficiently, yet retained virtually no warmth, an impossible combination unless the surface material was engineered for reflectivity. Some theorize that it might be coated with a compound similar to aerogel or metallic glass, materials that can scatter light but resist thermal absorption. Yet those materials were human inventions, not natural products of cosmic chemistry. Spectral analysis of the reflected sunlight showed a pattern known as a featureless continuum, a clean, unbroken slope devoid of identifiable absorption lines. This kind of spectral signature suggested a highly uniform material, perhaps metallic, but without the oxidation or imperfections that natural metals develop over time. It was a spectrum of purity, unnervingly perfect. To NASA's spectral engineers, it resembled the kind of light reflected from engineered alloys used in spacecraft coatings. The spectral reflectance was consistent across multiple angles of observation, meaning it didn't change as the object rotated, even though its brightness fluctuated. This suggested the material covering it was homogeneous across its entire surface, something rarely seen in nature. One of the more striking aspects of 3I Atlas's spectral behavior was the way it interacted with polarized light. When sunlight strikes a rough or uneven surface, it scatters in multiple directions, creating polarization angles that vary with each rotation. But the polarization data from 3I Atlas was stable, showing a consistent alignment, almost as if the surface were polished or deliberately structured to reflect light coherently. Polarization mapping indicated that its albedo might exceed 0.8, meaning it reflected over 80% of incoming light. This level of reflectivity rivaled that of polished aluminum or composite solar sail aerials designed to withstand the harsh radiation of space. The implications unsettled even the most skeptical researchers. At NASA's Ames Research Center, scientists ran comparative analyses against every known type of cosmic material. They modeled ice-covered bodies, metallic asteroids, and carbon-rich comets, feeding those spectra into supercomputers to compare against 3I Atlas's readings. Nothing matched. The closest approximation came from simulated alloys that existed only in theoretical materials science, combinations of titanium and exotic elements stable only under artificial conditions. Some researchers proposed that 3I Atlas might be a natural remnant from a supernova, a fragment of planetary crust vitrified under extreme heat and pressure. But even that theory failed to explain the uniformity and lack of spectral lines. Supernova remnants should show distinct traces of heavy metals, iron, nickel, or cobalt, but the object spectrum was blank, like a reflection off a mirror without imperfections. The absence of emission lines also baffled the astrophysicists monitoring it through ultraviolet spectroscopy. Normally, cosmic radiation excites surface atoms, producing faint ultraviolet emissions detectable even at great distances. But 3I Atlas showed no such activity. It absorbed high-energy photons and returned them as cold, sterile light, void of fluorescence. Some in the astrophysics science division began referring to it as the absorber, an object that took in the sun's light and returned only silence. The nickname spread through internal communications, a whispered reference to something that didn't behave like a rock or ice ball, but more like a shield. NASA's optical scientists began to question whether they were even seeing the true surface of 3I Atlas. What if the spectral anomalies were not due to the object itself, but something surrounding it, a thin layer of plasma reflective field, or a coating of particles that masked its composition? The concept was speculative, but so was everything about this discovery. A few models suggested that the object might be encased in a kind of shell, dust particles or frozen gases electrostatically bound by charge fields, acting as a self-sustaining shield. If that were true, it would explain the way the light seemed to slide off the surface without revealing its internal makeup. But how could such a phenomenon occur naturally in the vacuum of space, without any visible emission or magnetic interference? The team at NASA's Jet Propulsion Laboratory tried another approach, radar spectroscopy. By bouncing radar signals off the object and measuring the returned echoes, they hoped to detect density variations or hidden structures. But the radar returns were faint and inconsistent, as though the surface absorbed or deflected the signals in unpredictable ways. Some echoes came back with delayed phases, suggesting internal cavities or layered materials. It was unlike any radar profile ever collected from a natural celestial body. Rocks scatter radar energy chaotically. This object seemed to redirect it intentionally. The engineers recalibrated their systems multiple times, suspecting error, but the anomaly persisted. When all spectra from visible, infrared, and radar ranges were compiled into a single composite model, the resulting analysis produced more questions than answers. The object's light was deceptive. Its reflection properties created false indicators of distance, shape, and texture. Even the spectral redshift, the measurement used to determine how light stretches as the object moves away, was inconsistent, as if the light's wavelength was being subtly altered before reaching the sensors. One theory proposed that the surface could possess nanostructured layers capable of bending or filtering light, similar to metamaterials theorized for stealth technologies. These were materials that could manipulate electromagnetic waves, hiding or distorting their true spectral fingerprints. A T1 internal review meeting. A veteran astrophysicist compared 3I Atlas's spectrum to a cloaked signature. The phrase caught on quietly. The idea was not that the object was consciously hiding, but that it might be built or naturally evolved in a way that prevented its composition from being revealed through conventional observation. In a universe where most light tells the story of what it touches, 3I Atlas's light refused to cooperate. It was like a reflection off a false surface, smooth, sterile, and impenetrable. Even as NASA's most advanced spectral instruments pushed their limits, the mystery only deepened. The data did not lie, but the light did. Every attempt to extract meaning from it produced contradictions, as if 3I Atlas had been forged from a material meant to mislead. It was an object that absorbed inquiry and returned only uncertainty, reflecting the sun's light back into the darkness with a calm, unreadable silence that no equation could quite decode. When NASA and its network of observatories realized that 3I Atlas could not be explained through traditional astrophysical models, the floodgates of speculation opened across the scientific community. The data's smooth spectral readings, impossible reflectivity, erratic acceleration invited theories that ranged from the cautious to the extraordinary. Within days of the spectral anomalies being confirmed, researchers from Harvard, Caltech, the European Southern Observatory, and independent institutions began drafting preliminary models to explain what 3I Atlas might be. Theories took shape like ripples in deep space, each one born from the desperate need to give form to what the data refused to define. Some were rooted in physics, others in imagination. Yet all were united by a single question that echoed through the quiet corridors of NASA's research labs. What kind of object lies beyond the known boundaries of celestial classification? The first and most conservative theory came from those who still wanted to believe 3I Atlas was a comet, an interstellar body rich in ice and gas, similar to the earlier visitor to I Borisov. Scientists proposed that maybe its smooth spectral readings were due to volatile materials sublimating rapidly as it approached the inner solar system. If the object was losing its outer layers too quickly, the emitted gases might create a reflective coma that concealed the body beneath, making its surface appear deceptively smooth. Yet the theory faltered when infrared sensors failed to detect any trace of water vapor, carbon monoxide, or dust trails. Unlike 2I Borisov, which displayed a typical cometary tail, 3I Atlas remained eerily clean, a dry traveler without the shedding typical of frozen wanderers. The next hypothesis took shape around the idea of an asteroid, an interstellar fragment of rock or metal dislodged from another star system. Some researchers suggested it could be a remnant of a shattered planet, a piece of crust or mantle launched into space by a catastrophic impact millions of years ago. But asteroids, especially metallic ones, have distinct thermal and reflective properties. They warm under sunlight and emit predictable heat signatures. 3I Atlas, however, defied this pattern by remaining colder than the cosmic background at certain wavelengths. Its low thermal emission could not be reconciled with any natural mineral structure. Something was fundamentally off, as if the object was not only reflecting sunlight, but rejecting heat altogether. Then came the exotic theories, ideas that stretched the boundaries of known science, but were impossible to ignore. One of the most discussed came from astrophysicist A.V.I. Loeb and his colleagues at Harvard's Galileo project. Drawing parallels to Oumuamua, Loeb suggested that 3i Atlas might be an artificial construct, possibly a fragment of alien technology. The uniform reflectivity, non-gravitational acceleration, and low heat emission pointed to something akin to a light sail, an object propelled by radiation pressure rather than chemical propulsion. A solar sail made from ultra-thin material could, in theory, achieve such motion without expelling gas or dust. If 3i Atlas was indeed a remnant of an alien probe or debris from an ancient civilization's technology, it would explain why its surface seemed engineered to manipulate light. NASA did not endorse the claim publicly, but internal discussions revealed that the idea was not dismissed entirely. Some researchers noted the resemblance between its motion and the kind of acceleration expected from large, reflective surfaces interacting with sunlight. Meanwhile, another faction of scientists explored the frozen hydrogen hypothesis, proposed initially to explain Oumuamua's strange behavior. According to this theory, 3i Atlas could be composed primarily of hydrogen ice, a material so volatile that it sublimates even in the outer regions of the solar system. As it evaporated, it could generate thrust too subtle to produce visible gas trails, creating the illusion of propulsion without a detectable source. The challenge with this idea was that hydrogen ice is incredibly fragile. It cannot survive long journeys through interstellar space due to cosmic radiation. For an object like 3i Atlas to remain intact for millions of years, it would require shielding or regeneration mechanisms unknown in natural astrophysics. A third theory proposed that 3i Atlas might be made of nitrogen ice, similar to the surface composition of Pluto. Nitrogen can reflect light efficiently and maintain a smooth spectrum under certain conditions. But nitrogen ice also tends to erode quickly when exposed to solar radiation, forming visible tails or plumes. 3i Atlas displayed none of those. Its trajectory was clean, its motion stable, its structure seemingly immune to erosion. Scientists at the University of Arizona ran simulations using nitrogen models, but none reproduced the observed reflectivity or stability. The conclusion was quietly circulated: if 3i Atlas was composed of nitrogen, it must be from a source with properties unlike any planetary system we know. Outside NASA, independent astronomers began entertaining the possibility that the object was not entirely physical, or at least not behaving according to conventional material physics. Some suggested it could be a relic of dark matter interaction, an object whose composition interacted differently with light and gravity. Others theorized it might be a fragment from a dimension of altered spacetime, where electromagnetic behavior diverges from our known constants. These ideas, though deeply speculative, grew traction in online scientific circles and conferences. The more data NASA released, the more the mystery deepened, and the more room there was for extraordinary interpretation. Within NASA's internal teams, the emotional tone shifted from curiosity to unease. It wasn't just that 3i Atlas was unexplained, it was that it seemed to resist explanation. Its behavior mocked the predictive power of astrophysics. When researchers applied standard equations for radiation pressure, rotational dynamics, or spectral absorption, the models broke apart. The numbers didn't fit, the projections diverged, and the light curve refused to stabilize. Engineers used to finding beauty in patterns began finding silence instead. It was as though the universe had placed a mirror in front of them that reflected not understanding, but confusion. The alien technology hypothesis resurfaced more than once, often whispered rather than declared. Some compared 3i Atlas to the speculative concept of von Neumann probes, self-replicating robotic explorers that could travel between star systems, gathering and transmitting data. If such probes were ancient and derelict, drifting through interstellar space for millennia, they might appear inert, but still retain structural integrity. Their surfaces might be designed to withstand radiation, deflect heat, and mask their origins. But without proof of emission, signal, or communication, the idea remained in the realm of wonder rather than evidence. Others, perhaps more grounded, revisited the possibility of an exotic natural process. One idea suggested that 3I Atlas could be the byproduct of a stellar collision material ejected from a binary star system and crystallized under extreme magnetic conditions. In that scenario, its composition could include superconductive materials or metallic hydrogen, both capable of reflecting light without thermal decay. Yet these materials, while theoretically possible, remain unconfirmed in nature. 3I Atlas might thus represent a class of interstellar debris formed under conditions humanity has never observed directly, a clue to cosmic processes beyond our experience. As the debates intensified, NASA's public statements grew more cautious. Press releases referred to 3I Atlas as an unusual interstellar body and emphasized the need for further study. The agency avoided confirming or denying any exotic interpretations. Behind closed doors, scientists continued to debate the object's true nature, often with a sense of quiet fascination mixed with discomfort. The mystery had become more than scientific, it was philosophical. If the laws of physics could not describe what they were seeing, perhaps those laws were incomplete. Perhaps the universe still held domains where human logic faltered. And 3I Atlas had drifted from one of those domains into ours. Each theory, alien technology, frozen hydrogen, nitrogen, ice, or exotic debris, attempted to paint the same ghost with different colors. None fit perfectly. Every hypothesis left behind unanswered questions, unresolved data points, and contradictions that refused to yield to analysis. The scientific process thrived on uncertainty, but this uncertainty felt different, heavier. It wasn't merely a gap in data. It was a silence in the light itself, a refusal of the universe to reveal one of its secrets. And so, NASA continued to observe, theorize, and debate, searching for an explanation that would bring 3I Atlas back into the realm of the known, yet finding only more shadows in the spectrum of possibility. When NASA's team compiled the final series of images from the Hubble Space Telescope, it was meant to be routine, a data consolidation of multiple exposures taken over several weeks, each image calibrated for noise, distortion, and background interference. But as the last frame came together, something emerged from the quiet field of stars that would turn this observation into one of the most debated image sequences in the agency's history. The deep image of 3I Atlas did not simply show a traveling interstellar body. It revealed structure, luminosity, and patterns that no natural object had any right to possess. What was once thought to be a shapeless, cold fragment of interstellar debris suddenly appeared to have an order within its form, subtle lines, consistent reflectivity, and an aura of faint energy that seemed to move independently of the object itself. It began with the stacking process, a common technique in astrophotography used to enhance clarity and reduce background noise. Each exposure was aligned with precision, the light from 3I Atlas brought into focus pixel by pixel. As the composite formed, the first anomaly appeared, a faint halo surrounding the object, too symmetrical to be an artifact. At first, analysts assumed it was scattered light from a nearby star, a common interference pattern caused by diffraction. But when the same halo appeared in subsequent image sets from different telescope orientations, the pattern could no longer be dismissed as a coincidence. It was real, faint but persistent, outlining the object like a ghostly membrane. The halo glowed slightly in the ultraviolet range, not visible to the naked eye, but detectable through the filters used in Hubble's Wide Field Camera 3. It pulsed at intervals, not in rhythm with the object's rotation, but in soft fluctuations like the dim breathing of light through a fog. The pattern didn't match radiation, reflection, or gas emission. It was neither static nor random. Some researchers proposed that it might be a dust cloud ionized by solar radiation, yet no such ionization signatures were found in the spectral data. The halo emitted a faint ultraviolet curve, suggesting a process more akin to fluorescence than scattering. It was as if the space around 3I Atlas glowed in response to something within it, rather than the sunlight striking it. Further image enhancement only deepened the mystery. When contrast filters were applied to isolate the object from the background, thin linear patterns appeared near its surface. They were not ridges or shadows, they were luminous alignments, barely perceptible streaks that formed angular geometries. Analysts initially assumed these were compression artifacts from image processing. But when raw frames were re-examined, the lines persisted, consistent across all independent datasets. They formed what looked like a grid-like symmetry, not visible to human sight without amplification, yet too regular to ignore. The geometry did not conform to the chaotic, irregular structure expected of a comet or asteroid. Instead, it hinted at an organized lattice of reflectivity, something that interacted with light through alignment, not randomness. In public briefings, when asked about 3I Atlas, agency representatives repeated the same calm reassurance. It was a natural interstellar body, fascinating, but ordinary, and its mysteries would be studied for years. Yet the tone behind those words carried a strange, quiet. It was not the confident curiosity of discovery, but the tempered voice of those who had seen something they could not categorize. The calm was not the absence of panic, it was its evolution. A quiet acceptance that some truths arrive before we are ready to understand them, and that the universe does not owe us explanations for the visitors it sends across our skies. The story of 3 Atlas fades into the darkness of interstellar space. What remains is not closure, but wonder. NASA's initial panic, the strange light signatures, the unexplainable data, all of it leaves behind a humbling reminder that humanity's understanding of the cosmos is still in its infancy. We live on a small blue world orbiting an average star, trying to decode whispers from the infinite. 3I Atlas was one of those whispers, a fleeting visitor that challenged the boundaries of our science and the confidence of our explanations. It came from beyond the stars, crossed through our solar system in silent defiance of what we thought we knew, and then vanished, leaving only questions that echo louder than any answer we could have hoped for. NASA's response, part panic, part caution, part silence, reveals something profoundly human. When faced with the unknown, we cling to the comfort of definition. We label mysteries as anomalies. We normalize what feels extraordinary, and we file away what cannot yet be understood. But the universe doesn't pause for our comprehension. It continues, vast and indifferent, sending objects like 3I Atlas as quiet emissaries of a greater truth, that there is still so much we do not know, and perhaps cannot know. Science is not about certainty, it is about curiosity, disciplined by patience. The panic that swept through NASA was not fear of the object itself, but fear of what it might represent. The possibility that something out there moves with purpose, that the cosmos may hold intelligence, or at least intention beyond our own. Whether 3I Atlas was a natural wanderer, an ancient relic, or something constructed, it did what all great mysteries do. It reminded us of our smallness, our wonder, and our fragile need for understanding in an incomprehensible universe. In the end, the greatest discovery was not in the data, but in our reaction to it. The object is gone, but its legacy remains, a cosmic mirror reflecting both our progress and our limits. Somewhere in the quiet between stars, 3I Atlas drifts on, carrying secrets humanity wasn't yet ready to hear. And perhaps one day, when the universe sends another messenger our way, we'll be ready not to panic, but to listen.